Alright, in this video we're going to look at inverse trig functions, and we're going to talk about the difference between finding the inverse of a trig function and then finding the inverse where the inverse itself is actually a function, because there is a difference. So first we're going to look at a graph that we have looked at in the past. So that's a parabola x squared. So I'm going to go ahead and graph that in my calculator. I'm going to change my window to match up with this grid so that it looks the same on the screen as what I have on my paper. And you can look at the table of values if you need to find the specific values that you would graph on here. So I went over 1, up 1, and then over 1, up 3 to draw that parabola. And then I'm just going to fill in the information about the domain and the range. So we'll notice that the domain is from negative infinity to positive infinity, and the range is from 0 to infinity. Alright, so it says if you look up here, recall that the graph of an inverse function is a reflection of the original function over the line y equals x. So typically what we would do is just switch the x and the y variables and solve for y. That's what we can usually do. And then if you guys remember, the domain of the inverse is the same as the range of the original. So if the domain is based on x and the range is based on y, and I've traded all the x and y's, then in the inverse my domain and range would just trade. Now sometimes we have to be careful because you're going to restrict the inverse to make it into a function. For example, if we go back here, and it says in the instructions to turn off y1. I don't know how to do that. So, but it'll work out fine without being able to do that anyway. So we're going to go back to the y equals screen, and on here we're going to hit second program, and you want to go to option number 8, and I'm just going to scroll down so you guys can see what we're doing. It says draw inverse. That's what option number 8 actually does. So press enter, and that's going to show up on your screen. And now we're going to hit the vars button, and we're going to go over to y vars. So what we're doing right now, press enter in y1. So we're going to, basically we're coding into our calculator, I want you to draw the inverse of this function. And all it's going to do is reflect the whole thing over that line y equals x. So if we look at this, the points, over 1, up 1, and then we got 0, 0, up 1 over 1, and then we're going to see up 1 over 3. Because all of the points on the graph have just traded. Alright? And so if we look at this, we have the domain is from 0 to infinity, and we have the range is from negative infinity to infinity. So we did see that from the original function to the inverse, the domain and range have traded. But notice I did not call this an inverse function because this is not a function. It definitely does not pass that vertical line test. So over here it might be the inverse, but it is not a function. Alright? So it's an inverse, but not the inverse function. Alright, and if you need to write on your notes because it fails the vertical line test, that could be a helpful hint later if you're looking back and get confused. Now, if we think about doing this by hand, I'm going to do it over here. I'm going to say x equals y squared, right? So to do this by hand, we would trade the x and the y values. We would square root each side, right? So I have y all by itself, and the square root of x, I'm going to write plus or minus. Anytime I solve for y, by square rooting, I have to do plus or minus in front of the square root. So this right here, if I look, this matches the picture I just drew. I've got positive root x on top and negative root x on bottom, but that is not a function, so that's the first part we graphed. If we erase that minus and just have y equals the square root of x, then you'll notice we're just using the top half of that shape. So I start at 0, and then go up 1 over 1, up 1 over 3. And at this point, I have the inverse function. This is specifically a function because it passes the vertical line test. And what you'll notice is that if we take the range of the original, it is still the domain of the inverse function. But we had to redefine this range to make it continue to be valid as a function. So this range is going to be from 0 to infinity. So the domains of the inverse and the inverse function match up. So we can always find an inverse. That's just doing inverse operations. That's what I did with the plus minus. I was using my inverse operations. But for it to be a function, I'm going to have to limit it a little bit to make it pass the vertical line test. All right, hopefully that was not too confusing. So next, we're going to apply that idea to inverse trig functions. So go ahead and hit the mode button. You need to make sure that you're in radians for this to work properly. So now I'm going to go into y1 and I'm going to graph sine x. All right, and I can see it crosses at 0, and then this is a little bit past 3, that's pi, right, 3.14, so just a little bit past, and halfway in between it goes up to 1, and then again a little bit past 3 because we're at pi, and halfway in between it goes to 1. And if I look at the domain of this graph, I'm going to see that it goes left and right forever, so negative infinity to positive infinity, and my range is from negative 1 to 1, like that. So now we're going to do the same thing. I'm going to hit the y equals button, and I'm going to hit second program, and I don't need to scroll down. I can just hit 8 this time, since I know that's what I want to do. And then I'll hit the vars button again, go over to y vars, and now it's graphing the inverse for me. And you could see if my screen was square, it's rectangular, so it's kind of stretching it, but if it was square, then you could see that this is symmetric over that line y equals x, right there. So now if we're graphing the inverse, I know that it starts at 0 right here, and then this is a little bit past 3, because that's pi, right? And then it dips down to negative 1. And then it goes past 3 for pi. So we took the inverse, we used the inverse operations, but as you can tell, this is not going to be a function. It does not pass the vertical line test. So we're going to say this is not a function. We have the domain is from negative 1 to 1. And the range here is the problem. Negative infinity to infinity is not going to work because we're going to mess up that vertical line test. So now we're going to go back in and see what the real inverse function would look like if we are morphing this into something that really would pass the vertical line test. So you're going to do second sine, that's how you get the inverse. And then we're going to go ahead and graph that. And you can see basically what they did is they took this original graph and it did just this middle part from negative 1 to 1, and then it ditched all the rest. So everything else went away. So if we start at 0, I'm going to go ahead and draw this starting at 0. And then at positive 1, you can see that that was halfway between 0 and pi, right? That was the halfway point. And we could look that up on our calculator if we need to confirm that. So I'm going to just hit second graph to look at the table, and you can see that negative 1 is at negative 1.571. And if I figure out what pi halves is, that decimal, so that's where it's at pi halves. And this does not get an arrow, it's not continuing, it's just stopping right there. So we will still notice that the range of the original still is becoming the domain of the inverse, so that still works. However, the range of the inverse we have to limit if we want it to be considered a function. So, and it was from the lowest point is negative pi halves and the highest point is positive pi halves. So, just to help us out, when we are looking at sine inverse, we're going to go ahead and draw a unit circle. the values that are, I'm going to cover this up. So the values that go to pi halves, like pi halves is right up here, right? So anything from 0 to pi halves would be in quadrant 1. And then negative pi halves, if we're talking about a negative angle, would be down here. Here's negative pi halves. And so from negative pi halves would be quadrant 4, negative pi halves to 0. So if we are talking about using sine inverse, the only quadrants we are allowed to look at are 1 and 4, because that's where the inverse function is. So later on in this class, we'll talk about using inverses to solve. When we use inverses to solve equations, we'll be able to use the whole unit circle. But anytime they talk about an inverse function, if they specify that it's a function, that's when we have to limit it to only looking at these two quadrants. All right? And we're going to write a side note to ourselves, because you'll notice quadrant 4, you typically do not label quadrant 4 as being from negative pi halves to 0. You typically label it as 3 pi halves over to 2 pi. So we're going to write a note to ourselves. When using quadrant 4, specifically with inverse functions, if you're using the quadrant 4 angle, you must use the negative version. I was going to write the word must twice. You must use the negative version. So you're not going to be able to say 3 pi halves for this spot. You would have to call it negative pi halves. And that goes back to how we define our inverse function on the graph. Okay, next for cos, this is going to sound very similar to sine. So we're going to graph cos x. And if we graph this, I can see over here, so this is like 1.5, so that's the pi halves mark right there. So it's a little bit more than 1.5. It goes up to 1. And then at pi is when it dips down to -1. So just a little bit past 3 is when it dips down. Alright, and again, we're going to go ahead and hit the y equals button, second program, option number 8. And we're going to hit vars, and go over to y vars. And it's going to graph it for us, so I can see it's still going to 1 right here. It's still crossing a little bit more than 1.5, 1.5. And then at pi, it still goes here. 1, 2, 3, there we go. Okay, so again, the same problem. This is not a function. And I'm getting a little ahead of myself here. I forgot to do the domain and range. So domain is -infinity to +infinity. Range is -1 to 1. Okay. So over here, when I just used inverses to figure out what this would be, I got a graph, and the domain is -1 to 1, and the range is -infinity to infinity, and that's a problem because it doesn't pass the vertical line test. So now we're going to go back, and we're going to graph the actual cos inverse to see how we could turn this into an actual function. So what you'll notice here is it's cutting, it's using from -1 to 1, and it's cutting off the rest of the graph. So up here, this point was at pi, and then down here was at 0. So I'm going to put at 1 it's at 0, at 0 it's at pi halves, and then at -1 it's at pi. So it kind of goes like this. And then our domain here is going to be from -1 to 1, and our range here is from 0 up to pi. So on the unit circle, when we use trig, the inverse of a trig function to solve for a value, we're going to go from 0 to pi, right? 0, pi halves, pi, which means we can find our answers in quadrant 1 or quadrant 2 if we're talking about an inverse function, but we will not be allowed to use the other two because they're not part of the function. All right, and then last we're going to look at tan. So here, if you can see, this is crossing at pi, and then it looks like that 1.5 mark, that like pi halves, that's where the asymptote is. So it's a little bit more than 1.5. And then it'd be over here, kinda. This one is more of a rough sketch since we're doing decimals here. Alright, so the domain here is kind of interesting. So you have an asymptote at negative pi halves and negative 3 pi halves. And then over here at pi halves and 3 pi halves. And if we kept going, those asymptotes, let's focus more, those asymptotes would be at all of the odd halves. So I've seen this written a few different ways. So we're going to say all real numbers, we're including a lot of them, but the x cannot equal, and it has to be multiples of pi halves. So I'm going to use k times pi halves, so that k is telling me multiples of pi halves. And we're going to say where k is odd. So like 2 pi halves and 4 pi halves, those would be fine. But 1 pi halves and 3 pi halves and 5 pi halves is where those asymptotes would be. And then the range, I'm just going to say all real numbers. So I switched out of interval notation for this because interval notation, in my opinion, would be more difficult to write because you just have to have a lot of intervals. All right, so actually I'll bring this back over. Now we're going to hit the y equals button. We're going to do second program, number 8, vars. And now it's graphing it. You can see, so we're going to have asymptotes. This graph got real messy. We're going to have asymptotes in the same places, just horizontally instead. So I'll go ahead and draw those in first. And then this middle part looks like this, and then these ones are at pi, so I'm just kind of following the pattern that I know is there. And again, we have the same problem. It's not a function. So not a function. So the domain here is all real numbers, the range here is all real numbers, and then we're saying y cannot equal k times pi halves, where k is odd. So that is talking about those horizontal lines right here. Those are the values we can't have, those asymptotes that are there. So again, we're going to do the same thing where we hit y equals, clear that off, and we're going to do tan inverse to see what part of the original graph they kept that would turn this into a function. So what they did, if you guys can see, they got rid of everything except for this middle piece. And that middle piece is in between negative pi halves and pi halves. So I'm going to go ahead and draw those asymptotes in there. And so we're going to say that the domain is still all real numbers, but the range now is being switched, and it's from negative pi halves to positive pi halves. Oh, and I guess I need to, I almost mixed notations there. And we all know that's not right. So we're saying the y value is between negative pi halves and positive pi halves. And if you want your notes to be consistent with the other graphs that we did, you can write it this way now that we have a domain and range that are easier to write. So, and this is kind of familiar, right? This is similar to what sine inverse was. I mean, the range, or sorry, the domain is different, but the range is the same. So when we talk about tan inverse, when we're using inverse functions, we can only use quadrants 1 and 4. And again, I'm going to write the note to myself that when I'm using a quadrant 4 angle, you must use the negative version.